Hey guys, what's up? Sorry, I kind of threw this together real quick. Sorry about that. We got a 5 for 5 there. Somebody throw me a 5 for 5. Oh, there you are, Seventh. Hey man, thanks a lot. I truly do appreciate that, Seventh. I really do. I don't even have to ask. You always do that. Awesome stuff. Awesome stuff. Yeah, guys. We are definitely getting a solar storm right now. We're gonna take a look at that here in just a second. Let me do a couple things here real quick, like. Again, I just kind of threw this together, and we're gonna go with that. Let me say hi to everybody real quick, and then we'll get into it because I know I ain't been on here for a minute. So hey, Pamela, Root, Angela again, Lee, what's up, lady, Mr. Goody, what's happening, lady again, Sea Glass, Violet, Art, Tam Tam. Seen any? Yeah. Okay. Who was that? Hold on a second. Hold on. Hey, Frequency. Tam Tam got the cookie today. Hey, Carolyn. Menacing, what's happening? Okay, guys. We are going to go ahead and jump into it because I just kind of threw this together real quick. This was, it was very, very unexpected. We knew that something was coming, and I think I showed that to you guys yesterday. But this thing is, this thing got here quick. It was, it's moving faster than what they thought, I believe. Okay. And reason why, that's why it's going to hit us harder too. Right now, we're already into a radiation storm. You can see it right there. We're in a G2 storm right now. So just understand that's what's going on. This actually just started happening. So, and then if you guys can look here, they're talking G3 for 2 days here. Well, at least a little bit of each day. So that would be on the 3rd, and then that would be on the 4th. So the end of the day today, see they were expecting it to, kind of wait just a few minutes here, about another 3 hours before it got here. So it did get here a little bit sooner, and it is definitely stronger than what they thought was going to impact us. Obviously, they're saying G1 here on their forecasting, and they're going to be changing this. Make no mistake about that. But you can definitely see, and we'll look at the G3, what we can expect with that kind of a thing here in just a second. But yeah, so let's go here real quick. I want to show you guys a channel real quick because I think, oh, no, don't do that yet. I about ended the stream. Crap. Wow. Let's, what I do want to do here is I want to take you guys over to a channel, it's Magnetosphere, and she actually went live, like, really, really quick on this. She doesn't typically do that, so I just want you guys to understand that. She is she's a physicist, she's a scientist, she's a professor, she's got all those credentials, right? She also is trying to get space weather into, like normal weather forecasting. So I would suggest you guys please go over here and check her out, what she's talking about. So let me get, where is she at? She's probably up here at the top right now because she's live. Yeah. So this is her channel right here. I'm going to post a link to it. Copy. Paste. Hey Tommy, what's up? Carolyn, MJ, what's happening? Amy. Mark W. Uh-oh. Is that somebody I know? I don't know. Is it? What's the effect of this? We're going to talk about that, okay? But anyway, guys, she is live. Her name, she goes by the nickname Space Weather Woman, okay? Out of everybody that I look at, I would trust her forecasting more than anybody's. And I'm just being honest. That's just something that I've learned. She's very, very good at what she's doing. So I would suggest everybody go over and check her out. Look at some of the stuff she's got. I mean, she's got mini courses. You guys want to know solar weather, space weather? I mean, it's free college, dude. I'm just saying. It really is. It's free college. You can pause. She does informal and formal presentations here. But she does a really good job of that. So, anyway, guys, go check her out. That's kind of what I'm saying. So, if you could, please go do that. That would be awesome. Okay, so, now, this right here is not what is what causing this now. Not even close. This is what's causing it. This just happened on the sun right here. Now, that's not a very big flare, okay? I know it looks like kind of like a spike there, but it's really not that big. It didn't even get to M class. So, but there could be, I haven't even looked at it yet. So, we're going to go take a look at that here in a second. But, what I would say here, guys, again, you're looking at radiation, a small radiation storm right now. Now, it did hit here, and it looks like it's dropped. The protons have dropped out already. So, yeah, see, they've even taken that off of there. So we only dipped into that for a second. Now, that could have been, in my opinion here is, you see where this flare happened? That probably came from that flare. Okay, because we're talking an increase in protons. We're not talking geomagnetic storm when we're talking this. This is the geomagnetic activity here. We are definitely, I know it only shows a 4 right here, but this next one, when it pops up, is going to be G2, if not G3. Okay, so let's go over here to the Discover data. And so, again, guys, I trust this more than anything. This is definitely something that we look at constantly. This is just a better way to look at the data points, okay? Notice how everything was just straight across the board, and then all of a sudden, bam, right? Look at this wind speed here. The purple box, 727 right there. That's 727 kilometers a second. That's pushing close to 2 million miles per hour. So keep that in mind. For just about, this is just a rough estimate you can go by. For about 400 kilometers per second, that figures out close to be 1 million miles per hour. Okay? So that's what you can expect there. That's how fast this stuff is moving. You got to think, the sun's 93 million miles away. So it takes some time to get here. No, that's not the speed of light, Sherelle. But unless you were answering somebody's question in there. The X-rays from the flare, yes, those are moving basically at the speed of light. Okay, they get here and it's gone. That's here and gone. When light actually leaves the sun, it takes it 8 minutes to get here. So when your eyeballs actually see the sun, that light left it 8 minutes ago. So you're kind of, it's almost like looking in the past, if you want to think about it like that. But it definitely is, definitely pretty cool. Cool. Thanks, 7th. I appreciate you. Yeah, guys, I would go over there and check her out. You wouldn't even hurt my feelings if you left my stream and went over there. I don't know Tamitha. I've never had any conversation with her. But all I'm saying is I really enjoy the way she puts her stuff out there, and she's very, very accurate in what she's doing. Okay, she doesn't have to do any of it. That's the thing, she's been on the Weather Channel and stuff like that. So hopefully we can start working this space weather stuff back up into local news reports. It used to be that way. They would report on it once in a while. But anyway, the phi angle, see how the phi angle stayed really constant and then bam, started moving around. The BZ was like negative 13. Okay, maybe even more. That's the tilt of our magnetic field, basically. Okay, I'm not going to go into detail what that is, but we look for negative 6 or bigger. Okay, so that means it's actually pointing towards the south. And so that's what we look for. That's how we know, because if you take into consideration everything that's involved there, a southward facing magnetic field is just really the right setup to get a good geomagnetic storm. And so anyway, that's what's going on with that data there. The density jumped up real quick, and again, guys, this is probably why we got to such a high level really quick, because this was a very, very quick impact, and the density of it's quite high. Now, I've seen it way higher, but given a wind speed of almost 2 million miles per hour, you take that into consideration with everything else that's going on here, you definitely can see how this could be happening. And again, guys, we were expecting some of this. We were expecting, like a G1, but obviously that's not what we got. So, here's your aurora. Okay, this is one of the best indicators that we're getting geomagnetic activity. You can definitely see, because when we get the geomagnetic activity, it sparks aurora. So as we roll this through here, you see where that started bouncing around right there. And if you guys look at the timestamps, you can kind of see that we were actually getting geomagnetic activity, an uptick 3-4 hours ago. Okay, so as we roll through here, you see then there's where the brunt of it started to hit. Bam, right there. Okay, so obviously they were getting some really good aurora here. So if we keep moving here, it even gets, look how intense that got. Okay, now I anticipate this thing to kind of fluctuate. Okay, and why I say that, first off, it got here, this is stronger than what they thought it was going to impact us. Okay, and a lot of times with a big pulse of stuff, you will see variations in the conditions. It's not going to go to a certain level and just kind of stay there. It's going to kind of bounce around. I don't see it dropping out of storm level anytime soon, but you can see even just within those few minutes right there, how that's basically when the G3 conditions hit. And then you go here, you can see the aurora start to tail off a little bit. This won't last. This is going to be more intense, most likely. Obviously, I can't see the future, but I look for that to happen. Now look at the magnometers, the readings here. Obviously, you see what happened there. Bam. I mean, you can see when this thing hit us. On all this data is indicating right then. Okay? And again, and what we'll do here, see, this is also a good chance to show you guys that hey Tom, what's up, bud? You can see that this is a flare signature. Okay? Notice how the radiation storm part of it isn't there anymore because it kind of got flushed out. And see, there's that flare right there. So, yeah. Now, I think what's happening is we got this from the flare, and then check this out. This is interesting. All right? Now, I'm not sure if this is exactly what happened, but this is what I'm thinking's happened. We got that flare that I showed you guys a minute ago, and it brought extra protons or what have you, and this is X-ray here. But this is our atmosphere here, it got juiced up, and then the solar storm hit us, the CME, and as you're seeing, it kind of grabs it and pushes it away. See that? It flushed it out because we took a really hard hit. When did it hit, T4? It's hitting right now. So we will take a look a little bit more in depth here in just a second. But right here, guys, if you guys want to know like really quick conditions, this is where I would go. You can go here to this hub, NOAA Space Weather Prediction Center. Tells you the wind speed right here. I mean, you can get to just about anything you need to get to. And if you can't find it, all you got to do is go down here to the bottom of the page. Here's all the tools that you're ever going to need to go look at space weather. It's even got them subtitled. Models. You can go look at all the models, all the data. All that stuff is right here. Now, there's other places you can go look, obviously, and I take you to those places. but that's a good starting point for anybody wanting to understand this kind of stuff. So let's tell you what we'll do now. We will go over here to, actually before we do that, I want to show you guys the NASA Enlil spiral, which is here. And they've changed this just a little bit, but this is going to change again. Okay, because this, what they were expecting to hit us here is hitting us now. So as we're looking at this, you know, it's still the third. Well, is it? Let's see here. About another half hour, it'll switch over to the fourth UTC. Okay, so but this is hitting a few hours early. Now it's not extremely early or anything like that, but a lot of people are calling this like, and it is. It's a cannibal CME. So if you watch what happens here, and I'm going to zoom in a little bit. They've actually lowered the strength of the wind speed a little bit here on that. Now, I'm not sure if they're going to change that either, because something is, yeah, I mean, we really are taking a pretty decent hit right here. So, with that being said, let's zoom in on this one. Okay. Now, these are all those, and I think I showed them to you a little bit, but these are all those CMEs and stuff that fired off the sun yesterday. Okay, there's 1, 2, 3. There's 3 of them right there. And we'll take a look at them here in a second. There was one before that too. But watch what happens, okay? So what happens is, there's the first one. Okay? This one was possibly going to give us a glancing blow. Okay, but then this happens. You guys see that little one right there? That one fired off that direction. And we had one fire here. So there's actually 4 of them right here. Okay, so you got 1, 2, 3. And then we fire again right there. Okay, so, well, I didn't see that 4th one. The 4th one was kind of small. It might have been before this one. But the NASA model was showing a small one somewhere else also. So anyway, there's at least 3 of them here. But watch this back one catch up with the first one. See that? And because of that, first off, sometimes you get what's called an interplanetary magnetic shock wave. Now, don't make any misconception when I say those kinds of things that it's like a huge deal, because it's not. Okay, but it does intensify things if it happens at the right moment. What that is exactly what I'm showing you here. One CME catches up with another, or it could be solar wind, just plain solar wind moving faster than the solar wind in front of it. So when it catches up, what happens is that the magnetic fields of each atom starts interacting with each other, right? And it's not like they're not colliding either. They're actually repelling each other. But also, don't make no mistake, some of them do actually collide, into one another. But the majority of it is actually a repel effect. So when that catches up with that one in the front, it causes that shock wave. And if that happens at the right moment, that definitely could intensify everything, because they were able to catch that for the first time about a year and a half ago, at least in our solar system. So as you can see, they're calling it a cannibal one because it just basically takes over that first one. And if you look, they almost all become one. If you look as we go on out, see that? Now, if you'd have looked at this yesterday, this right here was probably about that wide, and it was solid white. So they've changed that, but I'll be curious to see if they change this again. Now, see how they even got that kind of missing us? And that would, this red color is right around 700, and that's what we're experiencing now. This is the wind speed. So with that being said, guys, I mean, this is a substantial hit, okay? So before we go any further, what I want to do is come over here and do what we can expect, right? I know everybody's just, what can we expect? And rightfully so, guys, okay? I'm not trying to be crazy there or anything. But just go over here if you guys are wondering. Just go to, like I just did, Space Weather Prediction Center. You can go down the bottom and you can get this same stuff I'm showing you. So as we're looking at this, first thing I always point out is the frequency of how often we see these things. Okay? I don't want to overplay this. I try my best not to do that. Even though I might sound a little bit excited, and the reason why I sound like that is because I am. I mean, this stuff interests me. That's why I do this, right? But I'm not in no way, shape, or form fearful of anything, okay? First off, this is not the one to be fearful about, okay? So just understand that. Now, we're at a G2 right now. We get that 600 times each sun cycle. 11 years. Hey, John, what's up, bud? So, yeah. And they're figuring 360 days in a cycle. Okay? So, yeah. That's how much they're saying in each cycle. So let me, sorry about that, guys. Anyway, so what can we expect with the G2? High latitude power systems may experience voltage alarms. Nothing bad's going to happen with that, but they could get some alarms. And then they go on to the long duration storms may cause transformer damage. Now they're talking high latitudes here, okay? That means closer to the poles. That's what that means. All right. Spacecraft orientation. They may have to do some corrective actions there to keep them in their orbit. All right. It says possible changes in, well, they're talking about drag right there. Because that's what happens, guys. When you add density, okay, you're increasing the drag that satellite's having to travel through. So it slows it down. So they have to, adjust it and steer it back into where it needs to be. And that's kind of a catch-22 too, because sometimes when they're trying to do that, when we're doing these things, they can't really, especially if we have radio issues. If that's happening at the same time, they have, that could be really bad for these satellites because they can't communicate with them. So how are they going to correct? See what I'm getting at? And I've shown you guys multiple times in the past how they shut these things down for safety sometimes. They have a fail-safe on the satellite themselves, number one. If it sees conditions or it starts sensing conditions it thinks it's going to harm the equipment, it will go into the safety mode. And they usually shut down for about 20 seconds. Not 20 seconds, but about 20 minutes, and then they'll boot back up. At least that's when we start getting the data again. So, what about La Palma with radio? Nah, I wouldn't worry about that, Sherelle. The La Palma thing is definitely something we need to keep our eye on as far as eruptions, but the radiation ain't going to affect that. It wouldn't affect that at all, I wouldn't think. But yeah, hey, you're right. So anyway, if we get to a G3, what can we expect? Well, we get that about a third less, or 2/3 less than what we get to G2. Notice how these really drop off in frequency as we get higher and higher. Okay, look, at G1, we get that 1,700 times. So, yeah. You know what I'm saying? Yeah, if you guys would, you know what? I would really appreciate if somebody would share this stream, like right now. If everybody would, that would be awesome. Because this is the stuff that I do this for. This is why I do this. So people can see this kind of thing. And I do it for the connection with you guys also, but for doing this space weather reporting part of it, I would love to get everybody here. That's what I like, right? Oh, thank you, Menacing. Yes, guys, please go check her out. She does a wonderful job. I can't say it enough. I mean, it really truly does feel like free college when you go over there. And she's not one of those people that's going to throw a bunch of big words at you without explaining it either. And the good thing about a YouTube video, you got a pause button and a reverse button. So, I mean, you can go back and listen and re-listen if you need to. You know, I didn't even know how sunspots were formed until I watched her explain it. And her explanation on that is awesome. Just so you know. Go to some of her playlists. You can go to those specific places and you will see it. I mean, it's awesome stuff. I can't say it enough. But, and again, guys, I've never even talked to her. And, you know, you don't even have to drop my name when you go over there. You can if you want. It's not going to hurt my feelings. But what I'm saying is that that's not why I'm telling you guys to go over there. I really, truly think that that's a good place to get information. All right? And you'll get stuff explained to you over there in a really good way. So, anyway, and again, she's not the only place you can go, obviously. I mean, I'm just saying, that's, you know, if you really want to learn, like, the nuts and bolts of space weather and stuff like that, and get, like, higher, you know, more of a higher education on it than what I could provide, that's definitely a great avenue to go down. I'm not one of her Patreons. I considered that. She does, like, really cool stuff for her Patreons if you subscribe to her Patreon channel. I don't, but that's, you know, I've considered it. So if you got, just go over and check her out. Enough of that, right? But anyway, G3, 200 times a cycle. Voltage corrections may be required. False alarms getting triggered on some of the protection devices. Okay, that's that stuff I was just talking about. The fail-safe, the safeties, right? Spacecraft orientation, you can get surface charging. This is a big deal for satellites and anything in space. Okay, because when you get surface charging, sometimes it'll short out some of the controls, and it'll make it really difficult to keep these things in the correct orbit, right? You know, when we get these, they're not so much worried about, like, the cameras themselves on these satellites. They're more so worried about the navigation systems on them. Because obviously, if a satellite goes down, it's gone. You know, and believe it or not, they can fix a lot of stuff from the ground when it comes with the camera and the equipment that way. They do software downloads from the ground, upgrades. They can upgrade this stuff from the ground. That's crazy to me, but it's awesome. And they've done that, you know. So I think it's just really cool. But anyway, the surface charging. Let's see here. Drag may increase again, right? Low Earth orbit. That's where most of our satellites are. Corrections may be needed for orientation problems. Yes. I already said that. Okay, now, other systems. Intermittent satellite navigation and low-frequency radio navigation problems may occur. Now, up to this point, they were talking about high-frequency radio. Okay, pretty much. Then you start getting into low-frequency up here when you start getting G3s, right? You get some low-frequency down here, but not like you do with the G3. See here, it says, high-frequency radio may be intermittent. Okay, anybody doing ham radio operations and things like that may be having issues. So, and who uses those radios? Well, most people use it, believe it or not. It's kind of a hobby for a lot of people. But don't forget, the first responders around the world use that. Okay? So, it can affect those kinds of things. Aurora has been seen as low as Illinois and Oregon. Okay? So, Ripper, if you're in here, man, Rip Curl Readiness, guys, you guys know Rip. If he's in here, if you see him, tell him to go get me some freaking Aurora photography, would he? Just kidding. But if anybody gets any of those Aurora photographs or takes video of that, if you want to send them to me, I'll be more than happy to show everybody. Okay? I think that would be cool. If anybody can get any of that stuff, it would be awesome. You're in Wisconsin? Awesome. Yeah, you might see some stuff there. So that's a G3, right? So again, as you keep going up, if you get to a G4, you can see stuff down as far as Alabama. Okay, it's like the 45-degree latitude mark, right? Anything, up to that point northward, you would be able to see Aurora sometimes. Now again, you start getting into G5s, they're talking 40 on the latitude, but it depends on how big of a G5 it is. If you get like what we call, like a big one, it would be, you can see aurora down at the equator. So, but yeah. So let's, and again, guys, I just kind of threw this together, so I am sorry. I hated to do it like this, but it is what it is. We got an interview tonight too, guys. If you guys are wondering, please come check us out on the lifeboat. If one of my mods could put the lifeboat link in there, that would be awesome. We got Joe Birdwell. He's going to come over. He's coming on. We're going to do an interview with him. He's already done one interview. He is he's a recovering meth addict, okay, methamphetamine, and he's 30 days sober. So he came on like when he was 2 weeks sober. So we're having him back on to, we're going to talk to him and see how things are going. So that's what I would say, So please come check us out over there. It's going to be a great interview. Great interview. This is real stuff, real life. Okay? So anyway, let's go check out SDO. And I want to show you guys the flare that happened just a few minutes ago. And we'll check that out. Okay, this is the 94 angstrom. It's probably going to be pretty obvious when it happens here. I haven't looked at it yet. Okay, I think it happened. You know what's interesting, though? I think I've seen it. Hold on one second. Yep, there it went. You see that over here? I'll zoom in. So, most likely, this was an actually bigger flare than what we got. So why would I say that? Because it's actually kind of off the side of the limb. It's not facing us. Okay? Hey, Grandma JJ, how you doing? So as you see this right here, watch what happens here. This is where that flare came from. See that? It looked like it flared a couple times in a couple different places there. So this is that same sunspot that was giving us issues before, right? This was the X-class flare sunspot. So as we look at that, bam, look at that. I mean, it blew here and here. So something destabilized pretty big over here, guys. Okay? Whatever it was, it could have just been the sunspot itself. Again, like I said, guys, remember you can get these sunspots, and if they don't have friends to play with, they never flare. They stay pretty stable. Let me back that off a little bit. Now I find it interesting that it looks like it flared over here almost at the same time. Let's find out. Yep, you guys see that? Now see, man, and that's what I'm trying to say. I've been seeing this quite a bit. I don't know what causes this to do this, but you're going to see that this side of the sun and that side of the sun flare at almost exactly the same time. Watch. Look at that. Okay? And it's interesting that it's in the southern hemisphere. Both of them are. Now let's look at the northern hemisphere. Well, look at that. That went off at the same time too. Watch. See that? All three of them at the same time. So, that, I don't know what causes that. Okay? I have a hard time thinking that is something we see a lot of. I've not personally been able to see that with my own observation. I'm not trying to make a big deal about it because I don't know what causes it. Okay? It could be it could be so many things, guys. Okay? I'm probably not even going to speculate here. It's just that, this is over on the back side of the sun here. And so is this. This is actually the side. I would call it more of the side, just over the limb. This seems to be a little bit more towards the backside, and this one's in the front. But they all react at the same time. So, you know, who knows? I don't know what's causing that, guys. I really don't. I just find it interesting. I'm definitely going to look into it and see what, you know, what could be causing the whole, because that would really be like a whole sun situation, because that's off the backside, that's off to the side, and this is in the front. So that's, you know, they're not even in relation to distance. They're not close to each other at all here. So, you know, and keep in mind this too, guys, that when you're seeing this stuff, the sun is connected to everything in our solar system, right? So you can talk about planetary alignments and everything else that's involved with all that. I'm not talking everything. Satellites, all that stuff, right? So, you know, just keep that in mind when we're talking about this. But again, I can't give you a solid answer on why all three of these would do it at the same time. It could be just a coincidence, I guess. I mean, I'm not saying that it is or isn't. I'm just saying that it is kind of an odd thing to see all three of these go at the same time. And I'll quit saying that. You're probably tired of hearing me say that. But let's look at it in a different angstrom here real quick. Let's look at it in the 304. Now, the stuff here on the sun is getting, it'll take it a few days to get here if it's coming our direction. Okay? Notice all the filaments around the edges, too. Now, this one here just fired one, and that looks like it's from the flare I was showing you here, guys, was down here. But this one was flaring, too, basically at the same time. This one looks like it fired off of CME with it. Small one. Doesn't look very big. But that one there would probably have the best chance of reaching us. This one over here, not so much. It is kind of facing that direction. Now, I'm not saying it couldn't, because it can. We've seen them flick around the side. We've seen them pop off behind the limb and almost do like a Houdini and flick back around and hit us. It's crazy, but it happens. Thanks, Tom. Appreciate you. So as you're looking here, guys, I mean, there's another one. So, I mean, we had basically 3 more flares at the same time, and all 3 of them looks like they ejected, so that would be a CME also. So, let's get out of that, and let's go to, we can go check seeds real quick. Now, this is today. All right, it's the coronagraph. This is LASCO C2. This is on the Soho Observatory, which is a satellite that's about 1 million miles closer to the sun than what we are. And it's always looking at the sun. Now, they can turn it and stuff if they want, but the majority of the time it's looking at the sun. All right? So as you can see, I mean, you can see each individual eruption here. And if you look at the timestamps, you know, you're not going to get to see the 3 I just showed you. Okay? Those happen too quick. Like, that isn't what you're seeing here. These are the other ones. Okay? So we'll back this up a day, and I'll show you, okay? Now, I don't know if this is actually the one that's hitting us now. If it is, that thing is moving fast. Okay? You see the big halo there? That would be the one that would be the cannibal. Okay? It's the one that caught up with the one in front of it. See, there's the one in front of it. Now watch, I'll show you the one in front of it here in just a second. Right there. And then there's the bigger one behind it was moving faster, obviously. So yeah. Now let's go look at stereo A, which would be our side view. Notice how many eruptions you guys seen there, right? That's quite a few. I mean, like a bunch. Okay, so this is basically confirming what I said a minute ago. You see how this is firing off the backside? That's that one we seen on the right side of the sun, down here on the bottom. Notice where this comes from. It's going that direction. So that one there on the right side of the sun, I know it looks like it's going to the left here, but I guess this could be the one on the left too. So both of these could be the ones on the sides. Don't know yet. We got time to look at it because it's going to take it a minute to get here, right? At least a day or two. Most likely 2 or 3. And remember, when we're looking at this, Earth is over here, okay? The satellite would be here where my cursor is, but just kind of pull it closer to your face as you're looking at it. It's about, I think right now, it's close to 2 months behind Earth in the orbit. So in other words, what that means is, if the Earth was to stop orbiting the sun right this second, in 2 months, that satellite would catch up to us. Okay? That's what that means. Hey, Leisure, what's going on, 7? So, yeah, I mean, that's definitely something that it's pretty cool if you ask me. You know, I know people, and that's it. That's what I try to do. Guys, I tried to bring things in not such a fearful way, right? This isn't nothing to be scared about. This is unexpected, I'll tell you that. But there's no reason to fear it. Because, guys, if the power was out, I wouldn't be able to talk to you or nothing right now. I mean, so everything is fine right now. The Earth is handling it. We're going to be just fine. But let me go over here and show you the Magnetosphere models. See, look at this. This is going to be cool. This is going to be cool. All right. See the speed? Guys, this is what this is. This is more of a high speed event than anything. Yeah, I think it's really cool stuff too, James. I really do. See the darker reds? You know, this only goes up to 600 kilometers per second. Okay, so anything faster than that, you're not going to be able to tell it. But, yeah, that's definitely, yeah. So let's, yeah, see that? I'll explain that in just a second, too. See these waves coming in? Bam, bam, bam. Look what happens here. See, watch us react. You see what's happening here? Watch what happens. This is basically our bow shock. It's probably not exact, but that's the point where the solar weather hits our magnetic field. That's basically our first line of defense, if you want to look at it in those terms. So what you're going to see here is magnetically, we sense that. Our magnetic field sense this stuff coming, right? So it tries to push out. Watch. See, it's just barely starting to do it. Now watch this next frame. See it pushing? It's a really good way to show you what's going on here. Look at that. Okay? Because you got to keep in mind, you know, when this thing hits, it's trying to push everything the other way. So we're pushing back against it right here magnetically. You can clearly see that with this image. Okay? So the next one, see, look at that. So you're probably asking yourself, why did it go flat? Well, because it's hitting that faster wind speed now. Okay? And then it starts really blowing out. See? Now the sun, now that CME is winning. It's winning that battle here for a minute. And then in the next few frames, you're going to see it get pushed towards the back. See it? See how that works? And see how we push back out again? Then we got hit again. Okay? And then it did it again. And this is what you're going to see. Right? I mean, that's some cool stuff, man. Now, this is the density. Right? This isn't speed. This is the density of the particles. And you're going to see similar stuff here. See us push out? Watch. See? I mean, you don't get any better of a capture than that. You can definitely see what's going on. I mean, it's not, there's no question there. Now, this is something that I want to stop and address here, because most people would say, well, that's 2 bow shocks, you know, and it kind of does do that, but it's not exactly 2 bow shocks. First thing you have to remember here is this is a 2-dimensional model. Right? This is not 3 dimensions. So when this stuff hits us, it could be actually hitting our magnetic field and going around. You know what I'm saying? Like pull it closer to your face and through, right? And over the top. When you think of our magnetic field, you got to think of it more of like a donut that's cut in half. And we're in the middle where the hole is. The rest of it's our magnetic field. So things can come in over the top, over the bottom, all the way through the side. So when things are moving from left to right here, sometimes it's hard to think that sometimes it could be coming closer or even further away. I just like to point that out because it definitely is something that we need to recognize when we're looking at these. Now notice how everything goes through low density. Why is that? The reason being is because the wind speed itself is pushing those particles fast and away. So it becomes less dense for a few. And then the density overtakes it again, and then boom. Boom. Okay? And it becomes this cycle of things that we see. Now, I haven't looked at this yet, okay? So I'm looking at it the first time with you guys. You're probably going to see a whole lot of magnetic pressure here going all over the place. So let me run this back here like that. And again, this is magnetic pressure. Everybody understands what pressure is. So as you can tell, this is going to be that we're going to push out against 2. See it? Starting to do it. See how we're pushing? Now, when I say pushing, it's not exactly what's going on. If you want to know the specifics of that, that takes a very long time to try to explain to people. But you can definitely see, you can even see some of that pressure get balled up around the side of our magnetic field. And and our magnetic field skirting that stuff away from us. Okay, you can see it down here. Okay, now, this is what I was telling you guys about, like, if you get 2 CMEs back to back. I was talking about this the other day. What happens is you're taking that first CME hit, right? And then some of that geomagnetism hangs around. And then you get hit again. And if it happens close enough to one another, it could really give you a harder hit on the second time around. Because our magnetic field is still trying to get back to a stable state. It's just like if you were off balance. Think of it that way. Say you were walking down the street. Well, the ladies would understand this. If you're walking down the street and you break a heel, right? And you're walking down the street all wobbled up. And then, God forbid, somebody accidentally brushes up against you, and what happens? You fall because you were already off balance. And that's kind of what's going on when you get that double tap. And that's why we talk about that. In my opinion, and a lot of people hold this same opinion, if we're going to be talking about, and we're not talking about this right now, okay? I don't want anybody to think that. But if and when it comes time for the big shot where our grid or something might have a chance of going down, most likely it's going to be something like a long duration event that has more than one thing involved. Okay? Because our magnetic field won't have enough time to come back to a stable position before the other one hits. And it makes things a little bit harder. So as you can see, I mean, look at that. Bam, look at that. Okay? And again, guys, I've not been able to show you guys these things very often. I know I've not showed you guys this at this level. I know I haven't. Not since I've had my channel up. We simply just haven't had that kind of activity. It's truly that's truly what I'm talking about here. Now, you can even kind of see, you see how we're kind of like this? Now, that's kind of what we're talking about with like the BZ thing we talk about a lot. The -6 and greater. Remember, the geomagnetic activity comes in towards the top and the bottom a lot easier on our poles, right? Now, remember, this is dawn and dusk. Okay, that's the cut you're looking at. Why? The Z cut is north-south. So this is basically a side view, and this is a top-down view. Okay? Or you could be looking at it, I guess, from the bottom up, but given the location of the sun to the left, with dusk being over here and dawn being over there, that would definitely be a top-down view, right? So as we keep moving here, we'll look at it here. Now, inevitably, and I have to say this because I would be very, very irresponsible if I didn't, you're going to have people out there telling you that this is something that it's not. Okay? I'm not downplaying this at all because I think that this is whatever it is, right? This is something we need to talk about and I needed to show you. But that's really kind of where it stops. And then, you know, you're going to have people out there that's going to tell you that this was, oh, they didn't expect this and the world's ending and everything else. And, you know, it's all this and all that. And no, we're not doing that here, guys. You know we don't. And so I just want to make sure you guys understand that. But I also want you guys to understand that this is a significant event. You know, first off, you know, this is not something we expected to see. And it's kind of like, you know, with the X flare that we just got through going through, where it actually didn't hit us as hard as we thought it was going to. The CME part of it. But make no mistake, the sun is awake. Okay? That's exactly what I would say here, because that's what's going on. Now, for all my Australian friends out there, Aussie, 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 let's take a look at one of their models. This is the Magnetosphere model. This is their version of what I just showed you guys. Okay? But this is so much simpler and easier to understand. Just so you understand that. You get the BZ right here. You get the proton density right here. You get the wind speed right here. This is representing the bow shock. These are our satellites. Some of them anyway. The key to what satellites they are right here. And what you're going to see is you get kind of like a compression with rapid expansion. That's that when we get hit and then we push back. Right? So let me play this. I guess we could. Is it going to load? Okay. This is the third right here. There's your time frame. Now watch when this thing hits. See it starting to flutter? Did you guys see that? Okay, so let me pause it. I'm going to take it back a little bit. Okay, because what's going to happen, you're going to see us push out. Watch. See how far we pushed out? You would think when you first get hit, it would push in. And it kind of does, but not always. So, and then we get compressed. Now see, we don't oftentimes see what I just seen right there. Let me back it up, and I'll tell you what I'm talking about. Let's go ahead and... Okay, so we're going to walk this 1 minute at a time. This gives you a 1 minute interval in between data points here. You see this thing jumping around? That's our bow shock. Okay, our first line of defense. What's going to happen here, you're going to see this thing get into the satellite line. That's how far back our magnetic field got compressed against us. Which is why you're seeing more magnetic pressure. It's part of it. You guys see that? Now see, watch. I'm going to see our bow shock? Watch the next image. Where'd it go? Well, you see this? It's way out here. It's off the graph. Now, you guys see these marks right here? Where they're putting measurements? These are Earth radius. So you take half the Earth. That's 5 half Earth distance. That would be 10. That would be 15. Okay? So it's way out here at the moment. Now, not right now, but you go to the next one, look. Within 1 minute, watch what this thing does. That's 1 minute. Okay? From there to there. So let's keep going with this. See it bouncing around? This is exactly what I would expect to see. So let me, I'm trying to get it to where it gets in there real far. I seen it breach our satellite line. Shoot, that thing reset, didn't it? Regardless, guys, there it is. Okay, I think it did right there. Hold on. Let's go forward here and see how. Okay, you see that? So what I'm saying here, guys. Hey, Paulo, what's up? Now, you see how close it is to our satellites. Why is that important? Well, like I said, guys, this is our first line of defense. So if our first line of defense gets pushed back to like here, what's that do? It puts the satellites out there with no protection. Hey, body and soul. So that means the satellites can be affected. You know what I'm saying? At least at a greater way. You see how it hangs? That actually did go inside it. You see it? And let me say this too. I would expect this with this kind of a thing. Okay, we've seen this happen before. This isn't something new. This is just something that's happening. Okay? And again, make no mistake, people. People are going to just blow this way out of proportion, but I do think that this is significant. This is definitely newsworthy at the very least. Okay? Yes, we had a cannibal. Yes, we did, Catherine. Okay, guys. So let's take a look at one more thing here. I haven't went over to spaceweather.com yet. See what they're saying. It says the cannibal CME described below hit Earth's magnetic field on November 3rd, just a couple hours ago. Solar wind data from Discover, which is this right here. This is the Discover data. That's what they're talking about. Spacecraft show a stair-step structure indicative of two or more CMEs pressed together. That's exactly what I just told you guys. A moderately strong G2 class geomagnetic storm is underway, and it could escalate to G3. That's exactly what I just showed you guys. So their basic, Dr. Phillips here is basically saying the same thing I was, at least on that point. Okay. By the way, give these guys some love, guys. They do great work. I say it every video, but I'm going to because that's exactly what this is. It's great work. Okay, always is. So here, and they're talking about the cannibal CME again. This is LASCO C3. Okay, it's the one I usually show you guys over on Seeds, but this is a zoomed out version of it. So yeah, it's on the Soho Observatory, just like the other one is. Well, I can show it to you. Okay, well, let's back it up a day. This view here is the same exact view as this. It's just zoomed out. Okay? So, yeah. Oh, yeah, guys. Julie's in there talking about biofreeze. I got like a mass amount of that stuff at my house. Biofreeze is kind of like a Bengay, but it works like way better. Most of you guys probably know what it is. It's been around now for a minute. You can get it on roll-on sticks and everything else. It's blue, typically blue. You can get, they're selling generic now, which is about half the price. It is kind of pricey, I will say that. but it works. So for muscle stuff and some joint stuff too. Just saying. Well, heck, he's showing it here too. Look, check it out. So yeah. Near Earth objects, guys. We'll go over that real quick. I don't want to spend too much time on this. Again, right now we're down here. So, there's really nothing to be looking at there a whole lot of. Okay? Not much going on. Near Earth objects are basically small meteorites or asteroids, those kinds of things. No noctilucent clouds. Not time for them yet. Getting close for the southern hemisphere, but not yet. So let's do this. Let's go over here. Okay, I'm going to post this in here. This is the lifeboat, guys. Tommy Scoville is the captain over here. He's quickly become one of my brothers for sure. I'm running the technical stuff in the background, and I talk a little bit during the live streams that we do every day. We're having Joe Birdwell on tonight, guys, here in about 45 minutes. So please come back and check this out. Come over here and check it out because Joe is awesome, dude. He was a methamphetamine addict and for 17 years and is now 30 days sober. We interviewed him. I think he was 2 weeks then or close to it. And we're going to follow his story. We're doing that with a lot of people. And he's a great guy. Great person. And so to be a part of somebody's sobriety like that is so humbling. It's ridiculous. It humbles me every time. And it's a great thing. It's a great feeling. As a matter of fact, helping other people go through these kinds of things helps me with my sobriety. All right? Now, I'm not saying that's for everybody. Okay? I'm 10 years, right? I've been sober for 10 years. So, I'm a little bit further along than a lot of people. And everybody has their own timeline. But come check out Joe. He could definitely use the support. Like I said, 17 years using meth every day. And to quit and be clean 30 days, man, I can't tell you how hard that has to be. I don't even pretend to understand what he's going through at all, period. But he's willing and he really wants to. He's eager to share his story, which is awesome. Because that's how people get help. People that out there that don't think you got a chance, let me tell you something, you do. Okay? And people like Joe is a definite example of that. So please come check him out. Here in about 45 minutes, well, about 40 minutes now. We're going to be going live over here, okay? And that's what I'll be doing. And then I'm going to come back on after the live stream over there, guys. I'm going to come back on my channel. We're going to talk about this some more as far as the solar storm. And I've been telling you guys I'm going to talk about some of my research. I've been exhausted, okay? And I finally got just a little bit of sleep today. So if I'm feeling up to it, I'm probably going to go ahead and start sharing some of that too. I hope you guys would come back and check me out later on tonight. It'll probably be around, 10:30, 11 Eastern. And I get that there's a lot of people probably already going to be in bed. I get that, all right? But I just wanted to be able to bring this to you guys and let you guys see this. Again, if you want to have a good channel to really get some good, solid information on what's going on right now. Okay, she's not live anymore. So this is Tamantha Scove. And again, guys, you don't have to drop my name. I don't. That's not what I'm doing this for. Okay. I just want you guys to have an avenue to go over there and you can learn. Yes. She's a professor at Millersville University. She just does a really, really, really good job. And I learned so much from her already. And, if you want to know the ins and outs about some space weather, I'm telling you guys, this is free college. It really, truly is. So that's what I would say. But anyway, guys, I think I am going to go ahead and bop off. I got to get ready for that other live stream. So let's check out NOAA one more time and see if there's been any updates to this. Yeah, see that? Oh, wow. That's G3 level. We are now in a G3. Okay? Yeah. We are in a G3 storm. So, with that being said, guys, I will most definitely be back. Now, I can tell you this. You see this green box? That's a mistake. They're updating their forecasting right now. I promise you. Okay? Thanks, Body and Soul. Thank you for being here. And moderators, thank you so much. Axe, you're killing it, brother. You guys need to go check him out. Go check out Hilly Billy. One of my good friends for a very long time, way before I even had an internet presence at all. You guys want a good Bible study on a Saturday? Go check him out on his channel. Angelo's holding it down in the Bronx. E-Rock's here. Tom Murphy, my brother from over at Mark Pires. You guys got to go check out Mark Pires, the Renaissance man. But tonight, the place to be is on the lifeboat, so we can hear Joe tell us his story so far, 30 days sober off of a 17-year meth addiction. It's amazing. Amazing. Hey, Jerry, what's up? Prayers for him, too. He's going through a lot of medical problems. Menacing. And thank you guys, everybody that showed up tonight. I'll be back, like I said. But come check us out on over on the lifeboat. And again, guys, please go check out Mark Pires, too. Please. It's good. It's good comedy. It's good music. I mean, he cracks me up. He really does. He's one of my brothers, too. So just know that. You guys know I've talked about Mark so much, you know. And there's a reason. Because, yeah. Positivity, guys. Positivity. He's live like 1,038 days in a row now. Kind of a crazy thing, man. I'm telling you. Yes, the lifeboat rocks, doesn't it, Body? Thank you for saying that. You guys are awesome. And anybody that's been over there, thank you for supporting us over there. I'm not talking financially, okay? I'm talking about just coming over there and watching and being a part of the chat. That's really our goal. We want people to build connections. We want people to get help, feel comfortable. And that's what's happening over there. It took on a life of its own. Tommy's got the wheel, I got the throttle, and we're like looking at each other like, what is going on? This thing has got a life of its own. Just let it go. So, you know, the old adage, Jesus, take the wheel. I'm letting it go. It's just going to go where it goes. It's taking off, let me tell you. So please come over there and check us out. And I'll be back on my channel here in a few hours, and we'll talk about some research that I've done, and I'll give you an update on this G3 storm. All right, guys? God bless. Yahushua saves. And you can drink this